Good afternoon, and welcome to Manchester. So, 125 years. Somehow I think that 125 is a more important number than 100, because 100 is only 10 squared, whereas 125 is 5 cubed. And I feel the weight of history pressing down upon us. The spirits of Edgeworth and Marshall, Keynes, Pigou, Beveridge, Robertson, Robbins, Hicks, Harrod, Mead, Phelps Brown, Caldor, Stone, and Hahn are all, I sense, with us this afternoon, and surprised perhaps and delighted by the last 125 years. So congratulations to the Royal Economic Society, and if you don't know, then you should now, that it's not only the 125th anniversary of the Society, but it's also the 125th anniversary of the Economic Journal that was founded at the same time. Now, this will be brief, but I would like to pick out the editors of the Economic Journal: Martin Cripps, Andrea Galliotti, Rachel Griffith, Morton Raven, Kjell Savanas, and Frederick Vermeulen, and ably supported by Benita Rajanis, who together have are not only very successfully running the journal, but have contributed enormously to the program in the next 3 days. It's a special program in large part, because of the 125th celebrations. 3 other names that should be mentioned now are Ralph Becker, James Lincoln, and just those two. Who's the yes, sorry, I'm so sorry. Who are our local organizers? Are they here at the moment? Could you stand up and... And last but not least, I'd like to thank the program chair, James Bank, and his co-chair, Johannes Spinnewin, who have been ably abetted by Narusha Vijay. So, could you stand up? James, please, stand up. So, happy anniversary, everybody. Let the games begin. Richard Blundell.
Thank you. So just for the first part of this session, we just have to award the Sargan Prize, and to do this will be Professor Richard Blundell from UCL.
Oh, thank you. Right. So there are 2 journals produced by the Royal Economic Society. One is 125 years old. One is a lot younger, and that's the Econometrics Journal. And each year, the Econometrics Journal gives out a prize, the Dennis Sargan Prize, appropriately awarded at the Sargan Lecture. And that's a prize for the best paper published in the Econometrics Journal for an author who's 5 years or less out of their PhD. And this year, the award is going to Cohen Jochmans. And where is Cohen? Ah, good. Come up here, and while you're coming up... I'll tell you just a couple of things about the paper. I'll be short about it, but it's a terrific paper, actually. I know it. I even teach it on the graduate program already, so you'll be pleased to hear that. The paper is called Pairwise Comparison Estimation with Nonparametric Controls, but don't let that put you off. If you've ever messed around with econometrics where you've got some control problem, like in a selection model or endogeneity, and you're using control functions, then the way you should think about dealing with that is by pairwise comparisons. It's a kind of matching way of getting rid of the unobserved or the observed selection term controlled by the control function. And the problem with that is that by putting that in, you always run into the problem is how do you do inference in that case, because you're often doing that in a 2-step way. And you should worry no more about doing inference because this paper covers everything. It really does. It's marvelous because it's got great theory in it and it's got a set of applications and simulations. So it's a very deserving prize for the Sargan Award this year. So come on.
Thank you so much.
Great. Thanks very much, Richard. So now to the main order of today, which is to introduce our keynote speaker for the Sargan Lecture. And this is going to be given by Mike Keane, who is Nuffield Professor of Economics at University of Oxford and has held past positions at NYU, Yale, and then more recently in Australia, where he is still involved in the Centre for Policy Aging Research. Mike has been a fellow of the Econometric Society since 2005 and has been on the council of the Econometric Society since 2009. He's well known to all of us for his work in many areas: labour economics, econometrics, consumer demand, industrial organisation, health economics and trade, really all brought together by, I think, what we think of as the Mike Keane way, with development and application of econometric technologies, particularly simulation estimation, and applying them to sort of structural and in particular dynamic discrete choice type models. So it's a great pleasure for us to have Mike to talk to us today. And Mike's going to talk to us about labour supply, estimating the roles of human capital and the extensive margin. Thanks very much.
Thanks. It's a great honor to be here. I was hoping there'd be some Manchester United fans in the audience. Some of you who know me may have noticed that I've grown a Roy Keane beard specifically for this occasion. Now, so I'm going to talk about labor supply and the importance of thinking about human capital and the extensive margin. Now we know that the study of labor supply, in particular labor supply elasticities, is an extremely important area of economics. Here I just list a few of the reasons why. We know that optimal tax rates are lower to the extent that labor supply elasticities are higher. We know that the plausibility of many macro models hinges critically on the values of particular labor supply elasticities. There's a big ongoing debate about whether differences in hours worked across countries can be explained by differences in tax rates, and that debate hinges largely on the values of labor supply elasticities, and you can go on and on about why this is important. Now, until very recently, there was a clear consensus in the economics profession, and that's an unusual phrase, right? It's not often a clear consensus on anything in the economics profession, but there was this consensus that labor supply elasticities are quite small. And here I'm just putting up a quote from a recent survey by Sayez and co-authors, where they say the profession has settled on a value for the compensated or Hicks elasticity that is close to 0. And this implies that the efficiency cost of taxing labor income is bound to be low. So I'll be saying Hicks a lot during this talk. If we look at the labor supply literature, I've listed here probably the four most classic papers on estimating the Frisch elasticity. And the way these papers estimate the Frisch elasticity is, loosely speaking, to regress changes in wages on changes in hours, and then you regress changes in hours on changes in wages and use some sort of instrumenting procedure to pick out the anticipated wage changes, because the Frisch elasticity is defined as the labor supply response to anticipated wage changes. And as you see, all these papers found extremely small values of the Frisch. Right? And theory tells us that in the standard life cycle labor supply model, the Frisch is an upper bound on the Hicks, which in turn is an upper bound on the Marshall. So, so these numbers are telling us that the Hicks elasticity must be very small. All right. So this group of papers contributed to this broad consensus that I just mentioned. Now, in recent years, there's emerged a challenge to this widely accepted conventional wisdom. And the challenge arises for two main reasons. First, there's a realization that models, if we take the standard life cycle model, and I'm thinking of, say, McCurdy 81, Heckman and McCurdy 80, the standard life cycle model where borrowing, savings, and assets are the only source of dynamics. All right? And if then we build in human capital into those models as an additional source of dynamics, you find that the data begin to appear consistent with much larger values of labor supply elasticities than the consensus would suggest. And this has been a line that I've been pushing for quite a few years. There's another line of argument that emphasizes the extensive margin. All right. And there have been quite a few people arguing that once we account for the participation margin and for the retirement margin, we realize that the data is consistent with much larger values of labor supply elasticities than were previously thought. And that particular line of argument is mostly associated with Rogerson and Prescott. So let me just describe in a bit more detail these two arguments. So I'll start with the human capital argument. So the claim I have made is that most existing estimates of labor supply elasticities are in fact biased downward, and that's because they treat wages as exogenous, ignoring the fact that work experience builds human capital. And this argument was made in a paper I wrote with Imai back in 2004, and was further elaborated in the survey I wrote in the Journal of Economic Literature in 2011, and in another paper with Rogerson in 2012. Right? And the intuition for this argument is extremely simple. So all I'm doing in this picture is plotting what data on hours and wages broadly looks like. Okay, this isn't a plot of actual data, but this is what it broadly looks like. What you see is that the wage, which is the blue line here, has a pronounced hump over the life cycle. Right? You see that hours also has a hump over the life cycle, but it's much flatter. Okay? Now, if you have those two broad patterns in the data, and you adopt the standard life cycle model of McCurdy 81, where you're assuming wages are exogenous, you're forced to look at those patterns and conclude that the response of hours to wages is modest. You're forced to conclude that the Frisch elasticity is small. Right? Now, what I've argued is that this is misleading because in a model with human capital, the wage is not actually the price of time. If you work today, there actually are two benefits. There's the current wage, but there is also the increase in future earnings that you get as a result of the additional human capital you acquire by working today. Right? So here I'm just defining something I'll call the effective wage, which is the current after-tax wage plus this the value of this marginal value of this human capital gained by working. All right? And in fact, this is this is not a new point. It was made earlier by Heckman in '76, Scholl in '89, prior to the paper I did with Imai in '04. The difference is that in these earlier days, they lacked the necessary computational technology to actually take this to the data and figure out what it implied about elasticity estimates. Right. Now, if you think about this return to an hour of work that comes in the form of increased future wages, this human capital investment return, it's pretty obvious that that's going to be large when you're young, right? And that as you get older and approach retirement, it's going to zero, right? So this human capital term has this shape, right? And empirically, that's what we find. If we want to know the effective wage rate, we have to take the vertical sum of that human capital return and the actual observed wage. So we have to take the vertical sum of the red line and the blue line, and that gives us the purple line, okay? And as you notice, the purple line is much less steep than the wage, okay? Now, suppose we go back and plot the effective wage against the price of time. Right. Now, if you look at this picture, it looks like hours are actually very responsive to the price of time. Okay. And that is why, intuitively, if you have a model that accounts for human capital, you're going to tend to find that the Frisch elasticity is large, or that people are quite willing to substitute labor intertemporally. Right? Now, so intuitively, what we did in Imai and Keane, which was a kind of quite elaborate structural model, but intuitively, all we were really doing is regressing hours on the effective wage rather than the prior literature which had regressed hours on the observed wage. Right? And what we found in that model is that our estimates implied a compensated labor supply elasticity with respect to permanent tax changes of about 0.7. So we got a Hicks elasticity of about 0.7. Right. Now, when this came out in '04, a figure like that was very high relative to the existing consensus. I think that the consensus has moved quite a bit since then. So for instance, you could look at this recent paper by Chetty in Econometrica in 2012. He surveys a very large number of existing studies, most of them based on short-run effects of tax reforms. And he concludes that the Hicks elasticity is roughly 0.58 based on his observations. So, so whereas our estimate seemed like quite an outlier 10 years ago, it doesn't really look like that much of an outlier now. Now, a key point about the work I did with Imai was not just that we found that elasticities were larger than the consensus suggests, but also that they varied in an important way with age. Okay. So if you go to the standard life cycle model, the McCurdy 81 type of model, the Hicks elasticity is a constant. It's simply a function of two preference parameters, which are invariant over the life cycle. Right? However, in our model, we simulated that the Hicks elasticity was only 0.45 when people were in their 30s and 40s, but that it rose substantially to this, the figure of 1.45, and then even higher when people are in their 50s and 60s, okay? I think this is actually one way to reconcile the earlier literature that found rather modest labor supply elasticities with this newer literature which is finding much larger elasticities. If you recognize that the model that Imai and I developed, as well as other models that have been developed recently with human capital, are still implying that elasticities are fairly modest for young people and middle-aged people, and that they then grow and become very large for older people, okay? And if you look at prior studies like McCurdy 81, they tend to drop all of the older people. They tend to screen the data, so they're only looking at prime-age men, right? So by focusing on what's going on with the older people, I think it helps to reconcile with what we're saying with what people have said in the past. There's a well-known paper by Eric Frisch where he specifically looks at labor supply of workers in their 50s and 60s. And I believe he gets a Hicks elasticity of about 1.3. Right? So once again, it's not out of the ballpark of what we're saying. Okay. Now, a third point I wanted to make is that once you put human capital into the standard life cycle labor supply model, a third interesting thing happens, which is that elasticities now tend to grow over time, or labor supply responses tend to grow over time. And we can see that if I use the model with Imai to simulate a permanent 1-point tax increase, right? And here is what happens. You notice that at young ages, say up to say below 40, the decline in hours is on the order of 0.5%. Right? But then once you get up to older ages, it's very large. Okay. Now, this is actually a different point from the one I just made, so don't get confused. What I'm talking about here is the effect on the life cycle of a single person as they get older, right? And what's going on is this individual person, because they are working less, their wages grow at a slower rate. And over time, their wages start to fall below the baseline, okay? Because their rate of human capital accumulation has slowed because they're working less. And eventually, if we look at, say, age 55, at age 55, their wage is 2.5% below where it would have been under the baseline. Now, recall we're simulating a 1% tax increase, so in fact, their wages are 3.5% below where it was in the baseline. So you get both of those factors contributing to the hours decline. So you get this sort of snowballing effect of a tax on total hours as people age. Right? Now, let's see here. Now, let me switch over now to the extensive margin argument. Okay? And what some people have emphasized is that the prior literature on labor supply, particularly male labor supply, has tended to just study employed men. Right? As I mentioned earlier, they do sample screens in these studies. They get rid of the young, the old, and the unemployed in general. So they're looking at prime age employed men. So they're looking at labor supply on the intensive margin, hours worked for those who do work. Right? It's perfectly possible that labor supply could be very unresponsive on the intensive margin, yet very responsive on the extensive margin. And all you need for that to happen is that the density of workers who are close to indifferent between working and not working be large, okay? The key point here is that has nothing to do with preferences. Basically, no matter what preferences might look like, you can have a distribution of wages and a setup of the technology such that you get a big density of people close to indifference in working and not working, close to the reservation wage. Right? Now, who are the people who are likely to be close to indifferent between working and not working? Well, they would be the young, right, because they have low wages. So if you have low wages, you're more likely to be close to your reservation wage. It would also be the old. The old have declining health and also declining wages. So for both reasons, they're likely to be relatively close to the reservation wage. Another group is married women with kids because they have a high value of home time, right? So, but if you think about classic studies like the 4 I mentioned earlier, such as McCurdy 81, they're basically looking at prime age men. So therefore, they're dropping the groups where this argument says we're most likely to see large elasticities. Right? So some key papers in this literature are a paper by French, Chang and Kim. I think that looks like a word processing error. It's C-A-N-G. Chang and Kim, Rogerson and Wallenius, Erosa, Fuster, and Kembrov. Right. Now, so if you want to contrast the effects of this human capital view versus this extensive margin view, what's the difference between them? Well, quite simply put, the human capital argument that I'm making says that we ought to see small elasticities for young people. Small elasticities until people are relatively old, right? The extensive margin argument, which has been emphasized by Prescott and Rogerson, predicts a different pattern. It predicts a U-shape, where elasticity should be large when you're young, go down in middle age, and then be large again when you're old. Okay. So, what I want to do here is integrate both mechanisms into a single model. Right? Get some idea of how important each one is, get some idea of what elasticity patterns you do in fact see when you allow for both mechanisms. So I'm now getting to the part that's actually new. So this paper on labor supply, the roles of human capital, and the extensive margin is joint with Nada Wasi, who's at Michigan, and who is extremely good at doing these complicated structural models. So here's the model structure. Okay. So we're going to have a model that includes human capital of a learning by doing form. We're going to have discrete choice of hours. We're going to have job offer probabilities. We're going to have a realistic specification of the U.S. Social Security system, which is a source of retirement benefits. We're going to include private pensions and health expenditures. We're going to have savings and bequests, and we're going to account for progressive taxes. All right. So let me just go through this model. Okay. So the choice set in any given age t will include consumption, and then work hours, which we're assuming belong to a discrete set. So it's either Annual hours is either 0, 500, 1,000, 1,500, 2,000, 2,500. There's a choice of whether to apply for Social Security benefits. Now that choice becomes relevant at age 62 when people become eligible, and it continues to be relevant until 74, at which point they have to claim benefits. Okay. The model has an annual decision period where the start will be when you leave school. Okay. So we're going to have 3 schooling types: dropouts, high school types, and college types. The choices for the dropout types begin at age 16, choices for the high school types at 18, and choices for the college types at 22. All right. And T equals 91 is the terminal period. So we assume that at that point everyone will die. Now, the utility function in this model is going to be the same as in McCurdy 1981. So the basic research strategy I've been following throughout all this work is to keep the baseline model the same as McCurdy 81 and extend on other dimensions, right? Just so I can be sure what those other dimensions are doing. Okay. So this is just a CRRA in consumption. There's a disutility of hours of work. That parameter alpha 2 has to be positive so that the pain of working needs to be convex in hours. B is a preference parameter, which is just a scaling parameter, so it doesn't really matter. Now, if you took the standard McCurdy 81 model with no human capital, these would be the expressions for the Frisch, Hicks, and Marshall elasticities. So you would see that they are very simple functions of the underlying utility function parameters, right? And they don't vary by age in any of the ways I've been describing, okay? Now, in general, I'm just not going to really talk about parameter estimates because I don't think they're particularly interesting. It's the simulation of the model that's interesting. So I just want to get to that. The wage process here, so K sub T is your human capital at age T. K sub T evolves according to the function given on that second line. As you see, it's a function of your lagged capital, your hours of work, and your age. Okay. There's also a shock to your human capital, which is persistent. So persistence is introduced through that epsilon T plus 1. Right. Now, the assumed process for this G function, okay, will include, as I said, your lagged capital. It also includes terms in hours of work and in age T. Now, the reason I have both is I also want this to nest a model where wages are exogenous. Okay? So it's possible in our estimates that the lambda 2 and lambda 3 could come out to be 0, and we reduce to a model where wages are completely exogenous. Right? I want to nest that case so that I'm not forcing human capital to explain all wage growth. Right? The terms in human capital incorporate the idea that there may be some threshold level of hours that you have to work before you learn anything. Okay, so that's what I'm calling H bar. Okay, so until you work at least H bar, you don't generate any new human capital. Okay, and H bar is a parameter to be estimated. All right. There are wage shocks that I'll assume are normal with standard deviation sigma. And down here, we see that there's a penalty for part-time work. So according to our current estimates, there's about a 15% penalty if you work less than 1,500 hours, which is pretty much in line with prior estimates. And there's some estimates of this function. I don't want to, again, go into much detail, but you'll notice that for the more educated group, the return to human capital investment is larger, as you would expect. Right? So for the college guys have a much higher coefficient on hours than the high school guys or the dropout guys. Right. Now, fixed costs of work. Okay, so fixed costs of work are very important for the extensive margin story. You need to generate a mechanism that will lead to the observed hours distribution, where you have a spike at 0, not a lot of people at low hours, and then most people working a fairly large number of hours. And you get that via these fixed costs. Okay. So here, the pre-tax earnings are not going to be just your wage rate times your hours of work. Right? There's this fixed cost FCH. Okay, so that you could think of that as how long it takes you to get to work, or you could think of it as how long it takes you once you're at work to actually get anything done. Okay, so that's the time you spend reading about the Kardashians on the internet in the morning or something. Then there's also a monetary fixed cost of getting to work. Okay, now this sort of nonlinear wage schedule is central to the models that Rogerson, Wallenius, and Prescott, Rogerson, and Wallenius have been working with lately. Okay. Now, I decided to put job offer probabilities in this model. I thought it was important to allow for search frictions. The idea being that one might get a distorted view of labor supply elasticities if one assumes that all movements in and out of employment are voluntary responses to changes in wages. So this model allows for the possibility that in a particular period you may simply not have an offer. Okay. So here we have the job offer probability is just a simple logit function that has some notches at various ages. Okay. If you look at the estimates of the job offer probability function, you see, not surprisingly, that college people are quite a bit more likely to have offers than dropouts. Okay. On the other hand, interestingly, the probability of having an offer rises with age quite substantially for dropouts and high school people, but not for college people. Right? The college people have high offer probabilities right from the start. Okay. Now we get to Social Security benefits. So in the US, people are eligible to start collecting Social Security at 62. Okay. Now, you can delay with roughly actuarially fair adjustments until 70. Right? Now, it's important to note that you can continue to work while you're receiving Social Security. So the decision to claim Social Security and the decision to retire are actually completely separate things. Right? Social Security benefits have always been a terrible problem for dynamic structural modeling because of the rule. that your Social Security benefit depends on your top 35 years of earnings, which means that the state variable that characterizes your career is the top 35 years of earnings, and that's just simply not feasible to keep track of. All right. So we follow work by Blau and French and Jones where they use an approximation to the benefit rule. So there's this thing called AIM, or Average Indexed Monthly Benefits. Your Social Security, all that means is the average of your top 35 years. Right? But what Blau and French and Jones do is they approximate AIM using this formula. Right? And all that formula says is that we don't update AIM quite the way we should. So if you get new earnings this year, we don't drop your lowest and put the new one into the new average. Instead, we drop the mean and put the new one into the average. All right. And it's a pretty good approximation. Okay. Social Security benefits, interestingly, are extremely progressive. You get 90% of AIM up to $9.8 thousand, and then after that, it's heavily taxed. Okay. Okay. So now there are, as I mentioned in the bottom, there are a bunch of details to these rules that I think I will just skip. Right? Now, private pensions are quite important, but we don't want to model that extensively. It's rather difficult on top of everything else. So what we're going to do is assume that from age 55 onward, there's just some exogenous probability you get a private pension. And we have fit a simple logit function to the HRS data to calculate those probabilities. And then we assume that if you do get a private pension, you're just going to get whatever the mean is for your education level. Right? And now we have progressive taxation. Okay. Now your taxable income in this model is your earnings plus your asset income plus your pensions plus any taxable Social Security. As I said earlier, you can collect Social Security and continue to work, and under the rules, some of the Social Security benefits are taxable in that case, but I'm not going to go into detail on how that's determined. But it is in the model. So in order to have a simple way to mimic the progressive tax system, we just fit this regression in blue to the CPS data. Right, CPS data on after-tax income and taxable income. Okay. And that actually gives quite a good approximation to the progressive structure. Right. And finally, I think this is the end. We're going to have medical costs, survival probabilities, and unemployment benefits. Now, to get medical expenditure, we use the MEPS data and just fit a distribution there. And then we just assume it's a simple quadratic in age with a kink at 65, because at 65, you start to get Medicare coverage and your out-of-pocket costs decline. Right? Survival probabilities taken from the National Vital Statistics reports, and finally, we assume there's an unemployment benefit. The current estimates are saying this is quite small, $2,500 a year, but you do have to remember that this is net of any non-pecuniary job benefits, which are not included in the model. So maybe that is reasonable. Oops. Oh, okay. Then we have asset accumulation. So people are free to borrow and lend across periods. The law of motion for assets is the usual, except we are including Social Security income, pension income, that unemployment benefit, subtracting off any taxes or medical expenditures. Right? Okay. Any terminal assets will be left as bequests, and that means we need a bequest function. We need to make an assumption about how people value bequests. All right. Now, this function we assume for the value of bequests looks kind of bizarre. But if it turns out, if you say you desire a handful of reasonable properties, it pretty much inevitably leads you to this. Essentially, you want something that's, you don't want it to be infinite at zero. You don't want the derivative to be infinite at zero. You want to be positive, because you do see people leaving some negative bequests, right? But you want to discourage negative bequests, right? So you want to have a derivative that is, you want to have a setup that's sort of discouraging negative bequests but not ruling them out, and this function does that rather well. The coefficient in front of that function b tells you how much the different groups value bequests. I actually have little idea how to interpret those numbers. Certainly the college people leave more bequests, right? So the fact that they put have a lower coefficient on them doesn't really mean much, I guess. Now, if you put it all together, the state variables in this model are assets, human capital, accumulated Social Security benefits, the AIM, lagged participation. Then starting at age 55, you've got lagged pensions. And then starting at 60 through 62, you throw in lagged Social Security status and the age of claiming Social Security. The age matters because, as I said, if you delay claiming, you get more per period because of the actuarially fair adjustment. Right? So obviously the state space of this model gets very big at age 62. Right? So in order to solve the dynamic programming problem, we're going to use grids for assets, human capital, and for the AIM variable. Right? Now, I want to stick to results, so I don't want to go into detail on how we do that. Right? The model is fit to at least three data sets. There's the CPS, the HRS, and the CEX. The CPS data is from 96 to 2005, all right? And the oldest people in that data will have been born from 22 to 26. So they'll be 70 to 74 years old at the start of the data set, all right? The youngest people will have been born in 85 to 89, and they'll be 16 to 20 at the end of the data set. Right? Now, the model is estimated by the method of moments, and the moments we fit from the CPS data are participation or employment, hours, and the wage. Right? From the CEX data, we're fitting consumption, adjusted by a trivial square root of family size equivalent scale. And then from the HRS data, we're fitting the age of claiming Social Security. Okay? There are some exogenous process I mentioned earlier, like for medical costs and private pensions as well. Right? But those are not fit. They're just estimated prior to the method of moments estimation of the model. Right? Okay, so assessing how the model fits. Okay. Now the model hasn't quite converged. It still fits. It's still fitting pretty well now. And I'm going to show you plots of several dimensions of the fit. Okay. So so here is average hours. So this is unconditional on work. So this includes the zeros. Okay. And the red line is the college people. The green line is the high school people. The blue line are the dropout people. Okay. So I would say it's fitting well on that dimension of average hours. The dotted line is the CPS. The solid line is the prediction of the model. Here is the fit to participation. Right? So this is just employment. Right? And again, all three groups seem to fit rather well. And then finally, we have hours conditional on employment. So this is without the zeros. Right? And I'd say this also fits pretty well. So what's nice here is that the model isn't just fitting average hours well, it's getting the decomposition into employment and hours conditional on employment pretty well. Right? Now here we have wages for the three groups. So those are the life cycle wage paths. And here we have average consumption for the three groups. All right. And is there, whoops, okay. So at this point, I would say I'm reasonably pleased with the way the model's fitting. Now, to get to some results, first let's look at the Frisch elasticity by age. And the thing here I find very interesting is what I highlighted in red. Especially for the college people, the Frisch elasticity is very low at age 25. And then it gets bigger later. So this is actually consistent with the human capital arguments I've been making. You know, when you're young, you're really concerned about acquiring human capital, and slight variations in the wage rate are not going to induce you to either work or not work, or work more or fewer hours. You're too focused on acquiring human capital. The same is true of the high school people, but it's not true of the dropout people. Perhaps because for them, the returns to human capital investment are not large enough to really matter. Now, if we look at the elasticity of lifetime hours with respect to a permanent tax, okay, we could either do that compensated and get the Hicks, or uncompensated and get the Marshall. And I'm very pleased with these numbers because, as you see, they're about 0.6 to 0.7. So they're very close to what I got with MI. So basically what it means is that adding in all these additional features has not blown away our earlier conclusion on that front. All right. Now, here is a graph of the Hicks elasticities by age. Okay. Now, remember what I told you earlier, that if I'm right, it should be the red line. And if Prescott and Roderson are right, it should be the black line, the U. Right? And it doesn't look like either of us is right. You do get them jumping up at the end when people are old, right? But you get this complicated pattern when you're young. And if you look at that closely, you know, I've been thinking about this for a couple of weeks now. It looks to me like the two forces I'm talking about are fighting against each other at young ages. And so on the one hand, you know, so look at the green line. When people are very young, right, they're very close to the margin of indifference between working and not working. And so it's fairly easy to get them to not work, all right? But then they get into their mid to late 20s and they start to think, oh boy, I better start accumulating human capital. Right? So the Hicks elasticity plummets, and they're very focused on putting in the effort to acquire capital. So I think it looks to me like the two forces are battling each other in those early years, and that's why you don't get either the U shape or my pure upward sloping shape. Okay. It does. Here's the Marshallian. With the Marshallian, you also see things jumping up at old ages, and you see they're low. Actually, they even dip a bit below zero at some places here. So both of these pictures are, you know, this picture in particular is consistent with the notion that if you look at people in sort of prime age years, you're not going to see big responses. Okay. Now, all I've done here is repeat the same graphs, except now I've put the Hicks and Marshall on the same graph for the college people. All right, and it makes a bit more clear what I was just talking about. There's this interesting pattern where the elasticity starts very high, drops down to be very low, and then bounces back up, and then it's flat, then rises at the end. Because the gap between these two lines is the strength of the income effect. And it appears that relative to the strength of the substitution effect, the strength of the income effect remains fairly stable throughout the life cycle. These are just, this is just a similar graph for the high school people, a similar graph for the college people. But I think I want to emphasize just how interesting I feel that these graphs are, because we've for years sort of been taught a standard model that says these elasticities should be flat over the life cycle. And here we're seeing that they're not flat at all. They're not even close to flat. Right. Okay, so to summarize, we've gone and added a lot of important features to the basic MI Keane 2004 life cycle labor supply model. We've got now corner solutions, retirement behavior, search frictions, progressive taxation. But I think despite these extensions, the main message of the paper remains that accounting for human capital does lead to higher labor supply elasticities than the earlier consensus would suggest. A key point you should come away with is that our estimates of the Hicks elasticity of lifetime hours are in the range of 0.6 to 0.7, and that's much higher than the prior work typically found. And as a result, the welfare cost of taxation of labor earnings is likely to be larger than previously thought. I think that economists should pay more attention to how taxes alter incentives to acquire human capital. And in particular, if if labor is really just another form of capital, then it raises questions about the various, the arguments for the preferential tax treatment of physical capital. Do those arguments, the sort of Chambly-Judd results hold in models where human capital is just taken as given, right? If human capital becomes another form, just another type of capital you can invest in, do you still get the result that there should be preferential treatment of physical capital? I don't know the answer to that, but I think it's a very important topic for future research, right? And thank you.
Fantastic. Thanks very much, Mike. Well, we've got 10 minutes for questions. Lots to talk about, think about there. We've got some microphones coming around, so I don't know whether anyone has got any questions. At the front here, Diane first, maybe, then Richard.
Thank you. Very interesting presentation. Did you say that you had done those estimates on male workers? Because if you're looking for interactions between the two types of effect, then female college-educated workers would, it strikes me, be exactly the place to look for it. And secondly, that for the college-educated workers, you had a dip at the older ages in elasticities. I wonder if you could comment on that.
I think in the literature on female labor supply, there's not much controversy that the elasticities are big. So I've done some work in that area myself, and I've surveyed that area. And there's, I think, a pretty broad agreement that, particularly for married women, labor supply elasticities are large. Right? So, in a sense, there's not a controversy there for me to step into. You see, because yeah, I mean, so there in fact are papers, there are existing papers that look at labor supply of married women broken down by education, and that allow for both human capital and the extensive margin. So there wouldn't be anything, and they do find big effects. So I agree with that. Just that I wouldn't have anything much new to say at this point. On those graphs, they do get a bit wiggly at the end. But you do have to remember that by the end, it's 75 years old. And so a lot of people have already retired by that point. So the simulations by the very end are based on pretty small numbers of people, so I wouldn't read too much into them.
Next.
Okay, yeah, a couple of, following up a little bit on Diane in a way. So, but nonetheless, the model is, you're modeling these decisions as if there are just single labor supply families, and I guess we think some of the offsetting effects, income effects, occur within families. But that wasn't. I've got a couple of little things. One is just on the kind of initial, the way we think about this. The perspective you're taking is one that's coming from the kind of macroeconomics analysis to some extent. Let me kind of put a bit of flesh on that. If you look at the kind of micro studies, they're typically looking at reforming, if they're looking at tax and welfare reform, they're looking at particular groups. And I think they coincide pretty much with what you have. So if you were looking at, for example, reforming low-income benefits, EITC, your results would suggest that, in fact, the human capital effects may be relatively small for those low-wage workers, and then, in fact, you may not need all of this apparatus to look at that, at least in the short run. So I suppose what I'm saying here is the perspective you're taking is really one that's been driven by the kind of the kind of revolution of looking at taxation in the macroeconomy. I think it has the advantage, though, because there's no doubt that that microeconomists weren't putting all the bits together. But I would still argue that microeconomists for a while have pointed out that the extensive margin at retirement was pretty important, and that for some groups, human capital was less important. So it goes together there. One thing on Marshall, just you've got these differences not disappearing. As you were presenting, a kind of puzzle there, because the Marshall elasticity I think of as a permanent, forever change in your tax position. And of course, as you're coming towards the end of your working life, forever isn't a long time, and you typically think the wealth effect from that is going to be relatively small, especially if pensions and that are a lifetime average. So one puzzle I had is why the Marshallian effect was holding up so well, even right at the end of the lifetime, but maybe that's a small point.
Oh, so the first point. Well, maybe I should emphasize this more, but I think one of the main results here that's interesting is the finding that for the high school dropout group, where human capital concerns are not that important, you don't find this this suppression of the substitution effect that I've been talking about in their 20s. Right? And I agree with in the work I did with Moffat, for instance, on welfare participation. I've never wanted to say, oh, I renounced that paper, and the answer I always give is I don't think human capital accumulation is a big issue for these people. So I agree with that completely. So what I'm thinking is, in terms of the second point, what's going on with the Marshall is a bit tricky, because as you get near the end, as you get near the point where they retire, so let's say they got to retire, they're going to retire by 70 at the latest, right? They're still going to live possibly till 90, right? So if you have tax changes at 70, the income effects become trivial. Right? And in fact, the Marshall, Frisch, and Hicks will all converge to each other as you know. Oh, they didn't, or they weren't converging? I think I think aside from the little wiggling problem, they're close to converging.
Any more questions? Yes, one here.
Two questions. First, there are substantial differences between the college graduates, those with some college, and the high school graduates. And I was wondering how you treated the some college group, whether you put them in with the high school graduates or with the college graduates. And second, I wanted to follow up on the point about family labor supply, and to suggest that within the Social Security system, for older married workers, the spousal benefits and the survivor benefits, at least for some workers, are quite substantial. And I was wondering whether they play into the analysis.
Yeah. I believe, as I recall, the some college people are grouped with the college. So we just had to go one way or the other. I'm actually currently working on a paper with Zvi Eckstein, where we're trying to model we're trying to actually integrate these male and female life cycle models and have a marriage market that connects them. And that is quite a project. So, you know, years ago I had this paper, Career Decisions of Young Men, with Ken Wolpen. Wolpen and I had another paper several years later that I wanted to call Career Decisions of Young Women. But he insisted on this very long title that no one can remember. Right? But what it really was Career Decisions of Young Women. And what I've always wanted to do, in each of those models, we just treat the men treat the women as exogenously showing up, the men treat the women treat the men as exogenously showing up. I've always wanted to have them two integrated. And I think rather than, I agree what you're saying is important, but rather than try to capture it in some ad hoc way, I want to actually have the two sides integrated in a marriage market and then making all these savings decisions, life cycle savings decisions jointly. So maybe we actually have some preliminary results already. So
maybe I can just follow up on that. The last thing you use is another dimension of complication, but I sort of think that elasticities, particularly of older people, may have been changing over time as well as age, in the sense that if you look at an older person now, they may have to care for their parents, maybe their grandchildren. And is there a sense in which you think that these early retirees are beginning to look like the female child caring type people with higher elasticities now over time, as well as over age? Is that something that you could tease out with these models? Because, I mean, in some sense, their other responsibilities are changing over time.
We haven't had a chance to look at any cohort effects here. To be honest, I think we got this model to work a month ago, got the simulations to work this month, so we could have it here, right? But in fact, when I was about to get the train, Nada sent me an email saying, "Well, what about cohort effects?" And I said, "No." But we will look at that. Yeah.
Very good. Thank you. Just before we finish and thank Michael for, I should just hand over very briefly to Ralph Becker, who has one announcement about this evening, and then we'll actually close the session.
Actually, thank you, James. It's 3 little announcements, but I hope you forgive me. Firstly, so tonight's the drinks reception. In your conference bags are details of how to get there, and we're all praying that it's not bucketing down. Okay, but it should be spectacular. The Museum of Science and Industry is fantastic, and I'm sure you'll all enjoy it. It's at 7 o'clock. In your, excuse me, in your registration packs, you will also find dinner tickets if you're here tomorrow. Do not lose them, and do bring them tomorrow. We don't have replacement dinner tickets, and they're also double as transport tickets. So please do bring them tomorrow. And lastly, everyone who's speaking in a EJ special session or in special sessions B2 and B3, your sessions are being filmed, and ideally we have your presentations beforehand to give them to the filming people. So everyone who speaks in an EJ special session, can you please come to the reception or read your emails? There are instructions there as well. Okay, thank you very much. But now I think it's time to thank Michael Keane.
Very good. Well, as I say, I thank Mike very much for kicking off with such a fantastic lecture. We have some coffee now, and I look forward to the rest of the conference. Thanks very much.